What's up, everyone? Welcome to my YouTube channel. I'm going to be doing videos on different data structures, and this is the first data structure in this series. I'm going to be starting off by talking about stacks, and in the future I plan on making videos on other computer science topics like recursion, or maybe in the future I might even start talking about web development. But the point of this channel is just to make tutorials that are easy to follow and kind of just describe different important concepts in computer science in just a really simple manner. So I hope you find this helpful, and I hope you enjoy the content. So stay tuned. Alright, here we go, guys. So we're going to start off by describing what a stack is, okay? And you might have heard this term before. A stack is something called a LIFO structure, okay? And all that means is last in, first out, right? So the last thing you insert into the stack is going to be the first thing that gets removed from the stack, okay? And so I'm going to show you what that looks like, okay? So let's pretend this rectangle is our stack, okay? And don't worry about implementation, guys. I'm going to be doing that in the next part of the video. Okay, so we have an A, a B, and a C, okay? The C is going to be at what we call the top of the stack, okay? Let me redo that P there. So the C is going to be at the top of the stack. At any given time, the only thing you can access is the item at the top of the stack, okay? So remember that. The only thing you can access in this stack right now is C. To get to B or to get to A, we have to remove the C, okay? So the way that would look is we do a function called pop, okay, which allows us to remove the C. So if we were to pop, then we would pretty much just get rid of the C, okay? And then what would happen next is that the B would become the new top of the stack, okay? And then to access the A, we would have to pop the B off, and then we can get to the A, okay? On the other side, if we wanted to add something to the stack, we do something called, oh, let me write it up here. We do something called a push operation, okay? So push just lets you add an item to the top of the stack, okay? So push, pop are the two main methods associated with stacks, and I'm going to show you how to implement those. We can do other things with stacks, like we can check if it's empty, we can check the size, we can do something called a peek, which is similar to the pop method, except the pop method will remove the item at the top of the stack, right? So that's the top again. The pop method will remove the item at the top of the stack, whereas the peek will show you the item at the top of the stack. It won't remove it, it will just show you it. Okay, I hope that kind of gave you an idea of what a stack is like, and now I'm going to walk you through the implementation. So here we go. The first thing we do, all I have here is a class called ADT stack, and the first thing I'm going to do is declare three variables. So we have a max size variable that's going to be an integer, or an int, sorry. We have a size variable that's also an int, and then we have an array of ints called stack. So you might be wondering why we have a max size and a size, and it's going to make more sense as we go, so you'll see. So first thing we do is we have a constructor that's going to ask the user to input a max size, okay, and we're going to use that max size to set the max size of our stack. So whatever they put, if they put 50, the stack is going to have the ability to store 50 ints. If they put 100 ints. If they put 1,000 ints. The point of that is simply to give the user the ability to control the size, because as you know in Java, arrays have a fixed size, and so we're just giving the user a little bit more customization so that they can determine the size of their stack. And then we're also initializing the size to 0. This size, you can kind of think of it as a pointer to the top, because that's actually essentially what it is. This, we could have called it top. In this case, we're just calling it size, but it's going to be incrementally pointing to wherever the top is. So if you were to insert a new item, size would go up 1, which is now pointing to the new top. If you were to remove an item, size would be decremented by 1 to refer to the previous item as the new top. Okay, so you're going to see that right here. So in our push method, we require the user to give us an item that's going to be an int, but this really could have been a string, it could have been an integer, it could have been a double. Our stack is whatever we tell it to be. It could store stacks, it could store ints, it could store strings, it could store anything you want. So in this case, we're just choosing to use an int called item. Okay, so the first thing we're going to do is we're going to check if size equals to max size, which would mean that our stack is full, we have no more space. So just throw a new runtime exception and tell the user the stack is full. We're done, we can't do anything from there. Now if we're not full, see whatever size is pointing to right now. Like I said before, size is going to be a pointer to the top of the stack. So right now size is pointing to 0, which conveniently makes sense because that's where we want to insert our first item, because it's an empty stack. So we're going to put in item at index 0, and then we're going to increment size by 1, so that the next time we try to insert something, we're going to insert it at index 1, right? So as to not overwrite the item we just stored at index 0. Now peek will return the item that the top of the stack is pointing to, but it won't remove it. Okay, so it only returns it, it does not remove it. Okay, so just see what we do here. We're checking if the stack is empty. If size equals 0, then stack is empty. In that case, just throw a runtime exception to the user and tell them there's nothing we can remove, or there's nothing we can show you, sorry. Then if stack is not empty, then whatever, if you remember what I did in index, size is always pointing to the first available spot. Because at the end of the push function we increment it, so it's always pointing to the first available spot. The actual top of the stack is 1 before size. So that's what I'm doing here. I'm saying just go to the index before size and return that item. Notice I don't remove it, I just return it. Okay, now the pop function is similar to the peek, except we're actually going to remove it this time. So the way we do that is, first we use our peek method to store the item that the top of the stack is currently pointing to. Then we're going to decrement size. Okay, so size is now pointing to that item that we just stored into temp. We're going to set that item to 0, which means essentially just nullify that spot. If this was a stack of integers, we would have said turn this to null, but in this case we're just setting it to 0, and the downside of that is that the user won't be able to tell if we meant to put 0 there or if it's 0 because we popped an item, but that's fine because this is just a basic demonstration. And then finally we're going to return the item that we previously stored here. So basically we're storing the item here, we're returning it here, and in between we're like actually removing it from the stack. Okay, and then here what I'm doing is checking if the stack is empty, and the way we do that is simply return if size equals 0, and what this will do is this will evaluate to a Boolean value. This statement will either be true or false, and so if it's true, then we return true, because if size is 0, that means we have not inserted anything yet, so we can safely assume the stack is empty. If it's anything but 0, then we're going to return false because the stack is not empty. Now pop all is just going to remove everything from the stack and start fresh. The way we do that is we re-declare stack as a new int array of max size with and then we reset size to 0. Now real quick, I'm just going to do a test function that I already wrote to kind of demonstrate some of the methods to really solidify them to you. Okay, so the first thing I did, I hope you can see that. I'll make it a bit bigger. The first thing I did is I set the stack size to 50. Okay, so I initialized a new stack and I made the max size 50. And then I printed out whether the stack is empty or not. So I called the isEmpty method and I printed it out. So if you can see at the bottom, we got true. That was our first piece of output. Okay, and then I pushed 3 items onto the stack. So 5, 10, 15. So if you remember my diagram, that would mean 5's at the bottom, 10's in the middle, 15's at the top. So now I do this isEmpty method again, and it returns false, which makes sense because we just added 3 items to the stack. And then here we do a peek method, which is going to return the item at the top of the stack, 15. And then we're going to pop it, which is going to remove the 15 from the stack and then make 10 the new top. And then I do a peek again and we get 10. So you could see all of the methods are working. Our stack is working perfectly. And that's that. I hope I answered all your questions. I hope it was very clear. If you have any questions or doubts, you can leave me a comment. Otherwise, let me know if you found the content useful. Leave me a comment or something. And hopefully I'll see you again for the next one. Okay, see you guys.